And ideally, just some guidelines. So in production network, if we can speak about some guidelines at the CCNA level, so ideally keep things simple, as you know. So do not use outbound ACLs because they pretty much don't make sense in most use cases. Use either inbound ACLs or global ACLs, but not both. There are some use cases again when both of them make sense, but generally not. So decide if you want to use an inbound ACL or a global ACL. Now, if you start a new firewall implementation and you run the proper code above 8.3, I highly recommend you to use global ACLs. Stop using the interface specific ACLs. It's going to help you tremendously in the future for whatever you want to do. You're going to have a bigger ACL, but it's going to be easier to move around the ASA and configure the policies the right way, other than putting interface specific ACLs. And realistically, if all ACLs are configured, so assumingly you're going to go ahead and configure both inbound, outbound, and global ACLs, then for a packet to be allowed by the ASA, it has to be allowed by the inbound ACL to begin with. That's going to be the first match. And then if the packet did not match any inbound ACL explicit statements, it has to be allowed by the global ACL. So it has to match if the packet did not match on any explicit ACL statement on the inbound ACL, then it has to match on a permit statement on the global ACL. If the packet did match on an inbound ACL explicit statement, then the global ACL is not checked. And finally, if it was allowed either by the inbound ACL or by the global ACL, a packet is not going to be allowed by both of them. It's going to be allowed by one of them, because in the end both of them are inbound ACLs, and it makes sense. So once the packet has been allowed by the inbound ACL or by the global ACL, then it has to also be allowed by the outbound ACL. So looking at our diagram in here, like let's take this traffic flow in this direction. Let's assume traffic would flow this way. And let's assume we're going to have a inbound ACL applied in here, an inbound ACL. Also a global ACL. And also a outbound ACL for whatever reason. So now if a packet flows in this direction, what's going to happen is the following. Step number one, I'm going to inspect the inbound ACL. Let me write it down in black. So I'm going to inspect the inbound ACL, because that's the first ACL I hit, the inbound ACL. And now what happens is that if I'm gonna match on a deny statement in the inbound ACL, I'm gonna drop the packet. If I match on a permit statement in the inbound ACL, so if I'm gonna match on permit statement in the inbound ACL, then go and inspect the outbound ACL. So the global ACL is going to be skipped. And that totally makes sense, because the global ACL is actually a global inbound ACL. But now if with that packet there is no match on the inbound ACL, so if with my packet I don't match on inbound ACL on an explicit statement, then go check the global ACL. And then of course the global ACL has to allow the packet. If it's gonna not allow it, I'm gonna drop the packet. But if the global ACL allows the packet, then go ahead and inspect the outbound ACL. So you see, it's pretty confusing and pretty, let's say, complex, and it doesn't make sense. So easy way is you go and you have two options. Ideally speaking, and in general, it's one. You go ahead and configure only inbound ACLs, on all interfaces, and you can control traffic however way you want. Or 2, you go and configure global ACLs. Global ACL, which is only one. But you never configure outbound ACL. So you go and configure inbound ACL per each interface as required, or you go and configure a global ACL and no other inbound ACLs. So you don't configure both. You never configure outbound ACLs ideally, and you never configure both inbound and global. You choose one of them, because otherwise the traffic policy filtering is going to be pretty complicated, and you may end up in weird setups where you don't understand what happens. Why is the traffic allowed or disallowed? Okay. Now the ASA, let's speak about ACLs. So the ASA firewall ACL configuration overview, just like on the iOS, ASA ACLs can match traffic based on source IP, destination IP, IP protocol number, TCP UDP ports, ICMP type codes, time ranges. So pretty much all of the options that are available also on the iOS. Unlike iOS, the ASA can optionally configure ACLs based on username of the user if a feature which is called identity-based firewall is enabled, where what happens, you're going to integrate your firewall with the Active Directory, and then through the Active Directory the firewall is gonna have, by reading Active Directory logs, is gonna have an IP to username binding. So then you can configure on the ASA firewall rules based on usernames, which users of which groups are allowed to send what traffic to the firewall instead of IP addresses. Like in iOS, any ACLs always is going to end up in an implicit deny unless otherwise overwritten by an explicit deny or an explicit permit. Like in iOS, ACLs can be of two types: standard, which means you can match only on source IP address. On the ASA, from the filtering point of view, highly not recommended. You're going to use standard ACLs only for other purposes, like for VPN split tunneling, for example, or what else? Nothing else comes to my mind now. For sure, VPN split tunneling is going to be one good example, or VPN filtering, for example. But not for firewall filtering, not for traffic filtering. You're going to always use extended ACLs, either inbound or global. As I was saying, you should never use outbound. And because extended ACLs, as you know, can match on any combination of source IP, source IP port, destination IP port, protocol, and so on. Like as I was saying with the routing configuration, unlike in iOS, ASA ACLs use subnet masks instead of wildcard masks, and unfortunately, the ASA ACLs are going to make use of the same naming convention for both standard and extended ACLs, and you cannot mix both in the same list. So ASA is basically, on the ASA, ACLs are only numbered, are only named and non-numbered. So if on the iOS you could differentiate between the standard or extended ACLs based on the number, if the ACLs were configured in numbered format, on the ASA it only supports named ACLs, which means you're just going to differentiate between standard or extended by explicitly configuring the ASA that that's going to be a standard ACL or extended ACL when you define the access list. Okay, now as you're going to see, once you're going to go to the configuration, the ASA file, just like the iOS, but is much more scalable and better, allows for the creation and configuration of object groups, which those are going to simplify ACL management by grouping similar objects together. I guess you're going to see in a couple, you're going to end up grouping all of your web servers or all your services which offer the same services, or all your services. You're going to see when I go to the configuration exactly how that enhances the configuration of the ASA and how does it scale it. And also, by using object groups, you're going to be able to do more granular changes, because when you're going to configure object groups, you're going to define the ACLs by referencing object groups. So then, for example, if one object group is referenced in multiple ACLs, then you just go in and change the object group, and then the ACLs are going to get automatically updated. So instead of, for example, building, let's say you need the same firewall rule to allow traffic from A to B in multiple ACLs. If you use ACLs with a default configuration, if you change the source IP for whatever reason, so let's say the source IP of the IP address of the source changes, you gotta go on all access lists and change that IP because the source IP changed. But if you would use object groups to define the source IP and then reference the object groups in the ACLs, you just go in the object group, change the IP, and automatically ACLs will get updated, because ACLs are going to reference object groups at that point. You're not going to configure ACLs with IPs, but only with object groups at that point. So it's much more scalable and more granular. As you're going to see, you have a couple of types of object groups. 4 specifically is going to be a protocol type of object group, where you can define basically the protocols, either layer 4 or layer 3. So TCP, UDP being layer 4, ESP, GRE being layer 3. You're going to have a network type of object group. We're going to define IP addresses or networks or subnet addresses. You're going to have a service object group where we define TCP and UDP port numbers. So just like the name states, it's a service, which service means only TCP or UDP. And also because ICMP is kind of like a special protocol, and you might want to do filtering based on the ICMP types and codes, there we go, we have a object group of ICMP type, where you can go ahead and define and filter based on the codes and types of ICMP. From the configuration point of view, pretty simple, just like on the iOS. You configure the access list, and then you apply the ACL to enforce the firewall policy, either inbound on an interface, outbound on an interface not recommended, or globally on the firewall in there. And of course, optionally, if object groups are being used to configure the ACLs for scalability, then you're going to go ahead and configure the object group first, and then reference the object groups into access lists in the end. From the verification point of view, you just say verify object groups. If you want to verify the object groups, you say show object group ID and the name of the object group. You can verify ACL configuration by saying show access list to make sure that what you have configured shows up properly on the ASA. And you verify if ACL is applied correctly using the show run access group command.